Now we'll discuss about transmission electron microscope. If you see, the transmission electron microscope is similar to the scanning electron microscope. The difference is the source. Sample is placed in between condenser lens and objective lens. In between the apertures, the sample is placed. This is only difference in transmission electron microscope and scanning electron microscope. Transmission electron microscope source we see the similar as a scanning electron microscope. Electron filament, tungsten or molybdenum, whatever we use, and that anode to accelerate that. And the condensing lenses, usually if you see that condensing lens means it must contain that aperture. From that aperture, electron beam is interacted with the sample. This is the sample. The electron beam get interacted with the sample. After that interaction, we will see in a transmission electrons microscope, we will see only transmitted rays. This transmitted rays focused onto the object lenses. These are everywhere in a scanning electron microscope and TEM. All lenses are electromagnetic lenses. Just like as one toroid, we say the toroid like structures. It's surrounded by electrical coil, the copper coil, and that we give potential to this one. This potential act as a beam. Then that's the object lens. Usually, if you say that object lens, it must contain aperture. What is the aperture activity? To get that fine beam out. Then this fine beam is molded on the projector lens. This projector lens change the direction of that beam, and this fine beam interact. The image is formed on that phosphor screen. In a transmission electrons microscope, we see the light rays passing through the sample. We'll see that only transmitted light rays passing through the sample. So we'll give that it will give that image on the phosphor screen. It will give the three-dimensional image, and it will give that entire sample profile, entire sample transmission profile it will generates. And typical structure, if you see the transmission electron microscope, we can find that source and condenser lenses. Then after sample, after that objective lenses. After objective lenses is contains the aperture, and aperture to it focus onto that projector lens to mold the beam, and it fall on that phosphor screen. This phosphor screen will give the three-dimensional image, and we can see the three-dimensional structure of each and every grain. In case by using of a TEM, we can study up to 1 nanometer. 1 nanometer grain size we can see by using of a transmission electron microscope. This is the typical construction of a transmission electron microscope. It will give that all crystallite structures, and each grain structure we can study morphology. We can